So the next thing we want to chat about is a new lecture I've added called Comp 1511 Code Gap. One thing that's happened over the years is Comp 1511 keeps changing pretty rapidly over the last couple of years, and a big part of that change has been cutting content out or tweaking some stuff. So we need to just spend a tiny bit of time touching on a couple of very basic C concepts that kind of weren't taught either intentionally or this course hasn't quite updated for it. So this is why it's called Comp 151 Code Gap. So it's like a really quick bring you up to speed on a couple of really basic concepts. So why are we doing this lecture? Because we need you to understand just a little bit more about C to complete Comp 2521. And the main things we're going to look at are for statements, which is a form of looping, asserts, which is a form of testing, and switch statements, which are a form of decision making, essentially. So first thing, before we kind of get into the details, is some style. Comp 1511 has a very strict style guide, right? There are things like you can't have multiple returns. I believe all of your variables must be declared at the beginning of the function, things like that. I haven't looked at it recently, but that's my memory of it. But in 2521, we will be relaxing some of those things. So most notably, I've kind of written down here multiple returns. So normal kind of programming, you would actually include multiple return statements in your functions, particularly for smaller functions, which we're going to be chatting about a bit. So there will be some relaxation on the intensity of the style guide that comes from 1511. However, we still do have a style guide, and you are still expected to adhere to it at all times. So that style guide's in the sidebar here. You go to style guide, and it's all written here. So if you're ever unsure, you can just look this up, and if you think something's not in here, you can just post on the forum about it, and we can help you out with that. So that's some basics on style. Now, for loops, my stupid head's in the way. There we go. This is one of the first things that we will be contrasting between 1511 and 2521. So in 1511, we would have had a simple program like this, which would have summed up 10 numbers and then printed the output. So I'm actually just going to copy this, and I'm going to open up the CSE VLab. I'm going to open my terminal. I'm going to make a new folder called CS2521. And I'm going to make a new file. I'll use gedit, which I will call, what was it called here? Nothing. We didn't give it a name. I'll call it loop.c. Now, if I paste this in here, this is a simple C program. And we know we can compile it with dcc-o loop and then loop.c, and it will compile. And then I can run it, and it will print the output. Right? Yeah, the indenting is wrong. The reason the indenting's wrong is just because I made a mistake. That's all it is. I'm sorry about that. I'll fix that up later. Sometimes it's the editor here is a bit weird, but that's okay. Who picked up on that one? Tuwaka. Excellent. So this is quite a simple program, right? We set a variable, we have a while loop, we do something in the loop, and then we finish the loop. What early programmers noticed when it came to while loops was that quite often, while loops had the exact same pattern, which was that you often start off by setting an initial value of like a counter, and then you have some kind of condition that you keep looping through, basically what's inside the while loop. And then inside the while loop itself, you would always do some kind of increment, like I plus equals 2 or I plus plus. So they were like, since we're always doing the same thing every time, let's just create and define a syntax that packages that up for us. So that's why you have a for loop here, which is basically we're just replacing while with for, except the difference is that the same information is just conveyed differently. So if you actually have a look at this, these two programs, I can actually show you the transformation pretty easily here, which is that a for loop, if I just comment out the while loop here, a for loop is kind of similar, except there are three parts of it separated by semicolons. And the first part is what we call the initializer, which we put here. The second part is the condition, which we already have. And then the third part is the increment. And the increment we can put in the third little section here. So a for loop, you don't need a semicolon at the end. A for loop is just three little components inside the bracket separated by a semicolon, and they're already things you were doing with the while loop. It just makes your code a little bit more concise, a little bit easier to read. Logically speaking, this is a lot more digestible than something with a while loop. And you'll see this will still compile the same. We're still able to run it. It'll give us an output. So a pretty straightforward kind of concept, while loops and for loops. Nothing too crazy about them at all. Are there any questions about that? By the way, there's a slight lag in YouTube because of streaming, so usually if I ask you a question, it takes like 10 seconds for me to actually get an answer. So got one all good. I'll stick with that. A few more seconds. Full screen. Thank you. Sorry. Just keep reminding me. Just in general too, these are recorded at 1080p at least. So even if it's not full screen, all the details still there if you want to ever zoom into it later. Srikar says, can you do the whole init, condition, increment in a while loop? No, you can't. That's just not how the language is defined. So you can't use while here like that. That's not possible. That's just not how the functions return. So two cool questions here. One is from Praf, which says, so we must use for loops instead of while loops. I don't think we actually enforce the use of for loops, but what I'll say is that pretty much every person I've met ever prefers them. So it's not so much we have to enforce them because they're just kind of clearly more readable to pretty much everyone. There are some circumstances where you want to use while loops. For instance, if it just doesn't follow this pattern, right? Like the point of for loops is that most while loops are kind of the same. Some aren't, but most of them are kind of the same. Tawaka, can you explain what you mean by compact braces? I've heard that term before. I just can't associate it with something in my head. And then the last thing here is Alan said that there's no return in this function. That's correct. This function, this main function should have some kind of return 0 or some kind of return exit success. Sometimes I'll omit just a couple of things from slides to make them a bit more compact. In general, your C program, I'm pretty sure by default, will return 0 for the main function if you don't include that, though this is generally considered better style to have the return there because it's obvious to the person reading it what's actually going to go wrong there. Some people have said in the chat that there's certain circumstances where for loops aren't appropriate, and it's as someone, I think yes, as autumnal says, for is specifically for counted loops. So basically, if you're using a counter, that's usually the bulk of the case you want to use a for loop. Sure. So Halogen says compact braces is having the new line after the brace instead of the blah blah, the parentheses, except with else if statements. So what do you mean new line after the brace instead of the... Oh, okay, I think I understand what you mean, but I don't think it's a big deal. Let me just double check. So like just as an example here, I mentioned to you that because I didn't, write this course, there's a few things I might just not know off the top of my head. So a good example is like no line break before the opening brace, line break after the opening brace, line break before the closing brace, line break after the closing brace, except when followed by the else if statement. Yeah, so pretty much what we have here, I'm pretty sure is, yeah, I'm pretty sure what we have here is an example of... I think you threw me off because when you said compact braces, I thought it was something different to what I was doing, but I think this is all in line with that. The style guide's super detailed. It's really great because it pretty much just like gives examples of everything. And occasionally I'll just be like super upfront as well. Like I will make mistakes on the style sometimes because like I just write too much code every day to remember like all these different style guides. So feel free to question it or point it out. You know, the lectures aren't gospel when it comes to code style. And again, sometimes we have to cut some examples down in lectures so that things are more like readable and stuff. Yeah, for sure. Everything in the style guide has to be followed. I'm just going to start to move on from that. A second full screen. I know. A second kind of yes, it's sorry. I'll tie this up. Someone says, "Is it enforced?" Yes, everything in the style guide is essentially enforced. So if it's in the style guide, you should assume that it's enforced. And if you're not sure, you can post on the forum, and we can answer that question for you. So this dictates to you how to do if and else statements and while loops and stuff like that. So follow the guidance in the style guide. The second kind of key structural difference in 2521 is that we're comfortable with using switch statements. So the point of switch statements is to make code cleaner visually and easier to handle in cases where you're dealing with essentially a bunch of equality comparisons where one of the things you're comparing is always the same. So you notice here how on the left hand side we have this simple C program, which I know doesn't have a return. It's just space, where we create a character input, we read it in with scanf, so someone enters a character, and then if that character is W, we say up, if it's A, we say left, if it's S, we say down, and if it's D, we say right. Otherwise, we say it's not valid. What you'll notice here is in all of these if statements, we're always comparing against input, right? So if you see a series of if and else if chains where you're always kind of comparing against the same thing, then you can use a switch statement. And a switch statement is essentially a shortcut way to say, you know what, let's just take input and let's just compare it. So this is the equivalent of if input is equal to W, else if it's equal to A, else if it's equal to S, else if it's equal to D, else that. So logically it's the same, right? Totally the same. It's just that the syntax is different and it's a bit more compact. Now, switch statements can be a little bit confusing visually. Let me first just like take this piece of code and we can run it. So I'll open another file and just call this, oops, that wasn't it. Why didn't that copy? Call this one switch.c. And then we'll go and compile that one, switch.c, and then we run switch, and you can see it's waiting for an input. We probably should have a printf here, so that it actually looks a little nicer. And then we might say y, f not valid. Okay, if I say w, and then I press Control D to stop it, it says up. If I press S, Enter, Control D, it says down. So in the case where it's like actually catching these particular cases here. Now, switch statement syntax is a little bit weird, but basically what happens is that when the switch variable matches a particular case, it will execute everything after the colon until the break. This is just a condensed syntax that we're using here. But in actual fact, in reality, you might actually see something that's like a little bit closer to this. So I copied this from a previous example. But you might actually see something that's like closer to this, because what's actually happening here, or you might even see it like that, is that everything after the colon for case will be executed until the break. So for instance, if I put a printf here and I say hello, that will also be executed here. It's a little bit strange switch because it doesn't actually use braces, which I think is the only confusing part about it. I think besides that, it's an extremely straightforward concept. But it doesn't use braces. So you kind of have to imagine that instead of it being like case W like this, because this might be like what you intuitively expect it to be, it's actually just using the colon and the break. That makes sense. Just a couple of questions. Caleb says, it waterfalls through if you don't have any breaks, right? Yes, the breaks are important. Just because it's the first lecture, I'm not going to get into like too much detail about the waterfalling. It wouldn't keep looping. It would just, I would encourage you to play around with it. So if you get rid of the breaks, some weird things happen, which is very few use cases I think are really useful for that. So in general, you want to include the breaks, otherwise it'll start processing different ones. And enough of you have asked me now that I'll just do it for you. But pretty much if you don't include the breaks, it just keeps going through and like printing everything else out. So for instance, you'll see here that if I run this one again, if I compile it and run it, and I type in W, it says up, hello, and then left, because once it hits a case, it actually just keeps going through it until it finds a break. And that's why we put a break here. So we usually want to put a break between every case and then the next case. You can omit it, but I think it just makes your code really ugly. And I've seen very few legitimate cases where it's useful. Sometimes it might be, but in general, don't try and be too smart, because you won't be very smart. Waleed says, how did you enter Y and F? Shouldn't scanf just take one input in that case? Yeah, I think that's because of this \n that I've included in scanf. So if I get rid of that and I do it again, I think if I just type W and then enter, it works. So because of that new line, scanf was waiting for a character in a new line. It's a bit weird, but in general, the point is don't include \n in scanf. So it's a very strange behavior. That's why I had to press Control D, because the pressing of enter was kind of expected, because it's like, oh, that's what I wanted, a character and then a new line. Yeah, so in summary here, switch statements, really compact, really straightforward to understand. Syntactically though, a little bit weird with the case and the colon and the break and stuff. I personally like to write them like this. I don't know what's in the style guide about it. Use switch statements sensibly. Yeah, so this is good because it means that there's nothing enforced, but generally what I would encourage you to do is to write them something like this. You have all of your cases indented with respect to the switch, and then everything inside the case, including the break, you indent, because then it's really clear to someone reading this like what the cases are. You could condense it all down to one line as well if literally everything's one line, though in most cases it might have more than one line. So this is kind of how I would write it personally, because I think that's very digestible. Though as long as there's some kind of clear pattern or consistency, that's what I think matters the most. Yeah, so someone's asked, what if I want to do something like, check, like what if my my if else's are not equals? What if they're like less than or greater than or something? Can I use a switch statement for that? No, you can't. So switch statements are designed for equality operations, not for what we call relational operations, which is where you're checking if something's less than or equal. I don't even think you can do not equal to. So it's pretty much always a double equals equivalent. So switch statements, to be honest with you, I really do use them rarely. And also, I would also encourage you not to be tempted to use switch statements if you only kind of have like two else ifs. Usually it's pretty much used in cases where you have a wide set of things, like usually 3 or 4 or more, such as keyboard inputs, like detecting arrow keys, or maybe days of the week or months of the year, like something where there's a substantial set of things. An if else block would just like look like a whole bunch of zigzaggy crap. And no, you don't need a break for default because it's at the end. If you added it though, nothing bad would happen. It would just be completely redundant. I think it's so awesome seeing everyone's questions on these things too. Like people are super engaged, asking interesting questions, being curious how the code works. What I'd say to you though is like, you don't need me. I'm not that useful. I'm just a hand and a brain. You can always try these things out yourself. You can just open VLab. You saw how easy it is to compile C. It's super easy. You just type it in, compile it, and then we're on our way. This is the structure of switch statements. This is on a slide if you want to look at it later. Yep. So that's just if you want to have a reference for that. We'll do a quick exercise maybe after the break. Yeah, so what I'm going to do is I'm going to do some asserts, which will take like 5-ish minutes, and then we'll take a break and we'll do this little exercise so we can start practicing some coding. Okay, so another thing that's kind of changed since 1511 is the way that we do testing. And there's this topic called Assert Statements, which are quite relevant in this course too. So I'm going to call this testing1.c. And you can see in this file, no pun intended, that I've got a function here called isEven, which takes in a number, and it checks if the number when divided by 2 has no remainder. So num mod 2 is 0. And if it has no remainder, then we... Oh, I might have accidentally not uploaded that. I'll upload that at the end. I'm sorry. That's okay. It'll be there at the end of the lecture. Just that last slide. I have to manually export them to PDFs, and sometimes I make little tweaks and then I forget. So what I might also do here, just for good practice, is I might hash define true to be 1 and hash define false to be 0, and we'll just do true and false here. So we check if it's even. It's pretty straightforward. Now in 1511, from what I understand, if you wanted to test your function like isEven, you might write like a test function like this, where you simply call isEven with a number like 2 and you check if it's not true. And if isEven of 2 is not true, then it's failed, and we printf it failed. If isEven of 3 is not false, then we printf that it failed, right? So if we implement this incorrectly, like for instance we check if it's 1, then watch what happens when we try and run it, right? We testing1.c, we run testing, and then it will fail. It'll say that those two things have failed. And if we get it right, we will know we got it right because it doesn't print anything. Yeah, standard bool's fine to include. Cool. So that's like how largely I've understood you've done it. That's what I've been told by your tutors. The one kind of thing that we're doing differently in this course is we're actually using a library called Assert.h. And Assert.h is a library that includes a really important function called assert. And what assert is it's a function that is given a condition, like an if statement. And like an if statement, its job is to, like, if it's true, it does one thing, and if it's false, it does another. But what an assert does is if the assert is true, nothing happens, and it just continues on the program. And if it's false, it crashes the program. It's like an instant fail. So what I can do here instead is say assert isEven 2 is not equal to true. Sorry, I want to check that it is true. Because in these cases, we were checking if something was wrong. We want to print something. Whereas you always pass what you want to happen to an assert. Because what does assert mean? I mean, we could Google it. We have the power of the internet at our fingertips. It says a state a fact or belief confidently and forcefully. So it's basically you're stating a fact confidently. You're saying, no, I'm confident that isEven of 2 should be true, and I'm confident that isEven of 3 should be false. So it's a lot more compact, which is really nice, and we can... oh, hi Kaya. It's nice to see you. Yeah, this was in the older version of 1511. So now in this case, what happens is that if we run DCC and then we run testing, it will actually pass because everything's fine. And then if we do this here, it will fail, right? And it actually gives us some more information. It says it failed on line 15. It shows you what assertion failed, and then it kind of gives you some syntax highlighting with DCC, that is. So if everything passes, it just does everything fine. If it fails, it gives you the errors. Now, one of my issues with the CSE programs is that lots of courses are, lots of courses are a little bit out of order. So there's a bunch of you that have done 1531, and it's like, oh, I already done this because we did PyTest, and there's some people that did like a different version of 1511 where they did touch this. So I'm mainly addressing this at people who've never seen asserts before. Yeah, so we're using GCC, but we're getting to that in the next lecture. Asserts are not, and actually I think, yeah, Autumnal has said a great line here I love, which is, this is for the developer, not for the user. So asserts are, you would never ship software that it thinks an assert might ever fail, right? Asserts are for developers to essentially sanity check their work. In the real world, if you're building a proper user application where they might enter a number and you tell them whether it's false, you wouldn't assert that their input is whatever. You would actually give them an error or some kind of printf. So this is mainly for like developers to test their code, not so much for for you to communicate with a user. So that's kind of the subtle difference. We're going to use asserts a lot in this course, and we will talk about different compilation methods in a bit as well. Praf says there is a lot of black box testing in this course, like the labs and assignments. Testing is not a major component of this course structurally, though it's like is in like assessment wise, like it is in some other courses, but you will be asked to do tests, yes. Like you will be asked to like write tests and do some other things. So expect to see it, but it's not going to be like 30% of your course or something like that. The focus on this course is understanding data structures and algorithms. So it's 3 o'clock. Let's take a 5, 7, I don't know. I just take a break till I'm ready to have fun with you all again. Let's take like a 5-ish minute break, and then we'll jump back into it, and we'll finish off this lecture doing the exercise, and then we'll move on to the next stuff. So yeah, let's chat in 5 minutes. All right, we're back. I was just thinking over the break, there was something I forgot to say during our first intro lecture that I just want to quickly interject with now, because I'm assuming at this point in the course you're all watching the lecture, which is that one thing that I hope you all try and keep in your mind throughout this course in particular is that our industry of computer science is still, generally speaking, a pretty bro-ish, boyish kind of culture. And I'm not attacking anyone here because it's an easy thing to fall into, but it's something I think I just want to point out in this course in particular, because one thing I've noticed about 2521 is it's a really technical course, right? Like some of I teach like 1531, where it's like a lot of teamwork and friendliness and all that kind of stuff, but this is like a very technical course. And what often happens in our industry generally is that once something becomes quite technical, once something becomes really about like raw coding ability, that's when a lot of like the worst culture kind of comes out, and you start seeing for lack of a better word, the boys trying to take up the space and be like, I know this and I know that and I know this and I know that, and it creates a relatively like uninclusive environment sometimes, and it's something that it's easy to participate in, and I definitely just notice it sometimes with students, and it can make it really alienating if you're like not really good at this stuff. It's the same reason I don't like to talk about games too much. Like even just talking about video games on the chat makes me feel a bit because like if you never played video games, you're like, is this the place for me? Like am I normal? Like I feel really disconnected, and sometimes people can feel disconnected just because they don't not very confident with C, and I'm not very confident with C. I'm just 5, 6, 7 years older than you, so I've just like seen it more. But when I was your age, this stuff was like freaking me out. So I guess it's just like something that I'll ask you once and I won't talk about it again. Is like throughout this course, your interactions and your tutorials and your labs and the help sessions and stuff, just be aware that if you do fit the kind of fairly narrow definition of what a computer science person is, which is generally a loud guy, or like a very confident guy, try and take a step back and see if you can help make some space for other people. Help people out without making them feel stupid. Bring yourself down to their level. I think it's just a very helpful thing, because you know, whether it's because of your background, your interests, your ethnicity, your gender, any other kind of thing that you're potentially marginalized on, you know, it's just good to include people, and this is one of those courses that separates them, because we don't want to build an industry where it's like, for example, you know, marginalized people are just like scared for you know, to express themselves because they're dumb. A lot of people are dumb, by the way, me included, and if you think you're dumb, you're kind of normal. The smart people are the weirdos, don't worry. Let's keep going. Thank you. I meant to include a slide about that, and then I just totally forgot. So we're going to finish off this lecture by writing a function called month name. I'm just going to copy and paste this whole thing into VLab here. So we're going to make a new file, call it month.c. Write a function month name that, so we'll write a function, call it void month name. We'll figure out what its type can be later. Int a. Great, and there's a comment. It accepts a month number, right? Okay, so we'll call this like a month number. Now, should this be camel case or snake case? Well, I'm going to check the style guide because we have a style guide. I'm going to look up variables, variable names, short variable names, lowercase letter. They can be either snake case or camel case. Use only one of these approaches in your program. Okay, and then we have functions, which I don't know if they have. I don't know if they say that. I don't know where they say anything about function types. There we go, function name, snake case or camel case. So I'm generally going to use camel case because it's, I don't know, I'm just used to that. So let's do that together in VLab. So I've got my month number here, and it will accept one of those. So month number is between 1 and 12 inclusive, and it returns a string, so we know it's going to return a char star, containing the month name. And we can assume that string will be read-only, use a switch statement to decide on the month. So what we're going to do here is we're going to do a switch statement, and what we're going to do is we're going to switch on month number, right? And you can kind of imagine where this is going. We might say case if the month number is 1, then what we'd like to do is say we want to return Jan, sorry. And then we might, so you could add break after this, but when it comes to early returns, returning is like the equivalent of breaking, so you don't really need to worry about what happens after the return. Now, I could kind of copy and paste this, like this, and do like month 2 and month 3 and everything else. So naturally, because these lines are so short, this is probably one of those cases where you might actually get rid of the extra lines and the indents just to make it slightly more readable. The thing about style to remember is that style is not a set of rules. Style's a principle, which is that we want code to be really readable. Like, code needs to make sense to someone, and style guides are generally best accepted practice. So if you ever feel really unsure about something, try and ask yourself the question, you know, what makes this more readable to someone who's never seen this before? And for something like this, where it's an extremely just visually aligned thing, it's kind of just easier to read it down like this. So I could, you know, say April, May, June, July, August, September, right, etc., all the way down to November, December. And then we just adjust all these case numbers here. 4, 5, 6, 7, 8, 9, and then 10, 11, 12. Now the other thing you might do here is you might just add some extra spaces here, just so these are all completely aligned, right? A superfluous space is totally fine here, I think. I'm just reading some questions. So Dev says, do our return strings need to have a \0 at the end to signify the end of the string? Hamish says, won't the strings be immediately removed since the function returns? These are great questions. So let me just run this function first, and we're going to use asserts here. Let's just demonstrate asserts. So I've got my function month name. I don't need to include anything yet because I'm not doing anything, but I might have a main function, and what I might do in that main function is do some assert. So I might assert that month name of 1 equals Jen, like that, and then we can try and run that. So let's do this now. We'll go DCC month oops, sorry, shouldn't do that. Should be DCC-O month, and you can see we've got an error here which says result of comparison against a string literal is unspecified. So if anyone tried to do this in 1511, you'd kind of remember that strings aren't ints or doubles, they're character arrays. So with C, you can't really just say, you know, I have an int array of 3 elements and an int array of 4 elements, and then I want to, you know, check if A equals B, or like. You can't do this, right? Because that just doesn't make sense. You can't say, is the dereference of an array equal to something else? So in C, we need to use our string compare, which I think is in string.h. I don't even remember, to be honest. So this is stuff that I just, I think it's in string.h. I remember the function well. Yeah, string.h. So we have this function, string.h, which allows us to use string compare, which is, and what string compare does is it takes in 2 strings, which in this case is going to be the return of month name 1, and it's going to be the string January, and we're going to check if it's 0. Because when you do a string compare, if they're the same, string compare returns 0. So when I go and compile this now, it's complaining because I'm using an assert without including assert.h. And here it's saying that my non-void function does not return a value in all case paths. Okay. Return null. Null. Sorry. Great. So now when I run month, it doesn't display anything because it worked, right? So asserts will not complain if things go well. It only complains when things go bad. Yes, there was a question here about like, is returning a kind of break? It is, because when you return in a function, it totally stops. So if someone gives me a number 2 here and I hit case 2 and then I get return feb, the function completely stops at that point. So if I put a break here, it is pointless because the function will never continue after the end of the return. And a default would also have worked here properly too. I should have added that. So we should have done something like that. I mean, both of them would be fine, but DCC was complaining because it noticed that there was a potential case where if someone entered like the number 0 or the number 15, then this function did not return a valid char star. Cool. So the other questions we got asked were around, and I mean, these have been answered, but not everyone can see the YouTube chat. So do we need to include a \0? You don't. You only ever need to include a \0 in a character array when you're making it yourself, essentially. So if I want to make a character array like this that just has the string @ then I might do something like this that has a \0 at the end of it. But when you actually physically write in a string into a C program, that's actually implicitly included there. We're using DCC. We'll talk about DCC and GCC next, okay? So I'll answer those questions. The thing about strings too is that I like Hamish's question about won't the strings immediately be removed since the function returns. So again, you would have learned that one of the things you have to be careful about in functions is you can't return something that's like created inside the function. So I can't create a local character array like what I had before. Oops. I can't create a local character array that's like string 2 and then I know I'm writing this again, I'm sorry. That's just like the letter A. I can't do something like this and then return that. Watch what happens when I try and return this, right? I'll just comment out this next block. So I go and compile this again, and it says address of stack memory associated with local variables returned. So this is because I've created something inside of a function and I've tried to return it, but because it's not a basic type like a char or an int or a double, it can't be copied out. Because if you return a char, an int, or a double in a C function, it will just copy it back out and then the function's destroyed. But in this case, you're trying to essentially return an address, a pointer to the beginning of an array that it will not the array will not outlive the end of the function. So once the function's finished, the array is deleted, so you can't return to the start of that. The difference though with what we call string literals is that they're actually stored a bit differently, like without going into the extensive detail of it. When you have a program that returns like gen like this, it's not stored on the stack. It's not automatically malloc. It's actually stored inside of a part of the read-only program code, which is also why you can't mutate it. Like, for instance, if you watch this, I'll do a similar thing. If I say like char string equals Hayden, and then I go string 0 equals, I don't know, maiden, just that alone will cause a compilation error, I think. Yeah, the errors aren't particularly like helpful. Like they're not really clear why this is complaining, but it's basically complaining because Hayden here is not a stack object. It's not a heap object because of malloc. It's basically stored in this super special part of memory that's read-only, and that makes it easier to program. Oh, thank you. Sorry, that's what it was. Thank you. Oh, it even runs. Oh, it crashes. That's even worse. Thank you for thank you, Hamish, for pointing that out. So the problem there was I was setting this to be a char. That's why it was complaining. A GCC compiler, which we'll talk about next, would not pick up on this, which is why we need to be careful. But yeah, in this case, it's crashing because it's basically like we just tried to set some read-only memory to be a different thing. So string literals are a whole separate thing. So just to recap, you've got 3 types of strings you can make. You can either make like a stack string, which is just your normal character array. You can make a malloc string, which, you know, size of char times 4. Or you can make a string literal, which is, you know, cat. These are the 3 different ways to do things, and generally you use the second one or the third one if you want the string to outlive the function, and then use the second one if you want the string to outlive the function and be like mutated down the line. Okay, I think I've kind of done this example to death now, and I really want to get to the end of this lecture. So I think I kind of covered a lot of the questions. Last one is Cameron says, is it better style to include or not include the breaks after the returns? I personally would not include them because they don't add any meaning, and I think most programmers are aware of what return does. So when you see return, you know it's a break, you know it finishes, you know that it's done in that program. Great. Okay, so that's pretty much the end of our Comp 1511 gap fix. Again, I'll give you all a chance to just leave some feedback on this one as well, which would be really good. Just standard feedback. You'll get used to this. We're probably going to do it like 30 times in the course, and I really appreciate your time. So yeah, fill that in. We'll get set up for the next one.